Who the man? Who the man? Who the man? Who the man?
Cross sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise. Teachers have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can...
All right, I'm here without Mr. Miller. We're going to go through the review packet so we can all be ready for our quiz tomorrow. So let's get right to it, shall we? Now, some of this might be a little hard to read. I apologize, but you all have your packet in front of you, so we're just checking answers anyway. Okay. So on the first page here, we're looking at this should be review from last unit, our categorical variables. Okay, so we want to know what percent of the people surveyed ordered popcorn were female. So it's the people who ordered popcorn. So that's that 44 were female. So that's 25 out of 44. Should have been 56.8%. Okay, same with the next one. The people surveyed, okay? The percent of the people surveyed, so that's everybody out of that 98. Okay, ordered hot dogs, well, that was 25. So our big one should have been 25.5% on the question B. Question C, we want marginal distribution of snacks. Okay, so, hot dog, peanut, popcorn. Okay, so the hot dog, that was, we're looking marginal distributions for 25 out of 98, excuse me, should have been 25.5%. We actually just did that one for part B. Okay, our next one, peanuts, was 29.6%. That was 29 divided by 98. All right, and our last one, 44 divided by 98 for popcorn, should have given us 44.9%. Okay. All right, now moving on to question D. Okay, the conditional distribution for snacks for females. So we just care about the female group right here. So that's this middle row. Okay. So again, this should have been review. So 13 over 46. 13 over 46 is 28.3%. That was for the hot dog. Okay, here we have peanut, popcorn. All right, so the next one should have been 17.4%. Okay, that was 8 out of 46. And then the last one, 25 out of 46, was 54.3%. Okay, so just watch the wording there. All right, moving to the next page. Okay, here we have our theater attendance. We needed to draw a histogram. Okay, now I included a photo of one I drew on the page earlier. Sorry that the writing is kind of sloppy. I did this on my calculator, so remember second stat plot. You can put all your stuff in the histogram. Starts at 102 is my min. And then I went up every 14. So then it was 116, 130, 144, 158, 172, 186, and then, I'm sorry, 87, and then 201. So I think the calculator did it by like 14.2. Okay, so you can see how it goes. Again, so what's this a graph of in B? Well, it's a graph of the, patrons per day. Okay, so I'll put the per day in there. Okay, describe the shape of our graph. Well, let's see. We got kind of two big humps here. So when you got two big humps, that would be what's called bimodal. Okay, now you can kind of maybe argue that it's somewhat skewed left, but you really is no obvious skew here because it's bimodal and you have two main humps. Really, all you can leave is that it's bimodal. It's not really symmetric because this one is smaller than this one. Okay, so we're just going to leave that it's a bimodal shape. Okay, D. What appropriate statistics describe center and spread? Well, it's mainly just looking at the middle of our two humps here. Okay, so probably, our median hump here would probably be around 116. Median hump here around 172, 170, somewhere around there. Okay, so generally when you got a bimodal, it's kind of hard to do appropriate stat. Okay, but you could probably say the median of the two. Okay, so we'll put that. I mean, neither the median or the mean is, for the whole data is going to really help you because most of them are going to come right here in the middle and they're on both sides of that. So basically just telling them that it's bimodal and looking at the spread of the data. Okay. All right, so are there any outliers? No. And how can we tell that? Well, there's really no, they all follow this nice little curve. They're all together right here. There's nothing way out here that's different from any of them. So we're going to say there's no outlier. All right, moving ahead. Okay, so now we're doing the back-to-back stem and leaf plot. Okay, and we should have shot a picture of this too. So here we have Atlanta, Philadelphia. Okay. Oh, oops, that was awful. Okay, so we'll start at 2, 3, 4, 5, 6, 7. There's nothing at 8. Okay. All right. For Atlanta, there was a 70, a couple in the 60s, a lot in the 50s. 2, 2, 3, and 5. In 4, there was a 0, 0, 4, 4, 7. For 3, 2, 2, 2, 5 2s. Okay. 4, 4, 6, and then 8. And then for the 2, there was a 6, 8, and a 9. Okay, so that was Atlanta. Philly was much more kind of centered around the 3. So it would be 5 for 2, and then there was 4 0s at the 3, 2 2s, a 3, a 4, 1, 2, 3, 6s. I'm starting to write too fast, it's getting sloppy. 8, 8, 9, 9. Okay, 4, it was just 4 zeros. Okay, 50, we had a 50, 53, 54, and a 58, and then 60, there was just a 61. Okay, so in general, we can see the general shapes of these. All right, and then for part B, it said which city had the more stories. Well, that would be Atlanta. How would I know that? Well, you can kind of look. They had more up here in the 50, 60 range, and even a 70 way out, or a 7-story building way out here. But you could also see that you could also find the mean, okay, or the median, and that would be different. This would be higher in Atlanta than it would be for Philadelphia, okay? And then the last question says, does either city have what would be considered an outlier? Well, if you actually typed in and figured out the upper and lower fence of this data, you could use that during your calculator, you actually find that Philadelphia, okay, good old Philly, has some outliers, and that would be at 53, 54, 58, and 61. Wow, 60, there we go. Okay, and 61. All right, we find that because, again, I found the upper fence, and then these were far to the right of that. Okay, so it may help you. It's not super obvious here on the stem and leaf plot, so you might want to make a box plot of that. It makes a little more sense, and you can see how it's very, the Philly one is very skewed right. Okay, most of everything's down here in the low end, but then we kind of skew it out here with these high 50 and 60 numbers. Okay. All right, moving forward. Okay, question 1, I'm not going to read the whole thing. Okay, basically it's looking at the distribution of the data. And if you choose the right one, you would have chosen D. Okay, the distribution of the number of visits is skewed to the left. That means down here it's skewed left. Okay. The number of visits ranges from 1 to 16 because right out here is 1 to 16. Don't make it go to 15. There's one more out there. Okay, it's centered around 14. Yes, and has many students visiting 15 times. That would work. The outlier of the distribution, we had the high, occurs only once, and the high number of visits was at, the next highest number it would visit was at 8, right? Yes, right. Once and then, so there's a big gap here between 1 and then 8. All right, sorry, kind of confused myself there at the moment. All right, page, where are we at? I guess it says page 2, but it's really not. Okay, we're making another stem and leaf plot. This one we wanted to make a split stem. Okay, here we have male, female. Okay, so we start at 0, 0, 0, 1, 1, 2, 2, and then 3, 3. Okay, remember the split stem, we go 0 to 4 on the first one. Well, that's none here. However, the males did have a 7, an 8, an 8, and a 9. Okay, at 1 they had a 2, 2, 3, 4, 4, 4, 4. And if only I could write not on an angle. Okay, they had 1, 11 with the females. Okay, but then they had a 15, 16, 18, 18, and a 19. Males had a 15, bunch of people at 16. There were 3 of them, yes. 17, 18, and then 3 19s. Okay, 20. A couple at 20. Then there was a 21, 21, and then a 23. Okay, and we are done with the males. 25, 5, 5. Well, I am terribly sorry, my bad. 20, that should be a 1. So here, we're going to cross this out, made a little mistake here. Okay, so 20 for the female, there was a 21, a 21, and a 24. Then we should have had the 5, 5, 5, 6. There were 3 at 27, 2 at 28, 1 at 29. Then there was 2 at 30, 1 at 33, and then there was 1 at 35. Okay, so now you can look at this. You can see that the males are much more centered down here in the low teens, probably around 15, 14. Okay, whereas the females are much centered in the 20s. So if you look at what this says, all right, body fat. Male, this is telling us that males have a lot lower body fat than females. Whether that's actually true, we don't want to get into that. All right, so 3. Okay, flipping in. If you read the whole, if you look at the comparison here, we want B. Okay, the cluster is, the Northeast is unimodal and very symmetric. It's also very tightly clustered. This standard deviation is not very big, whereas the Southwest stores, very, very wide standard deviation, okay? So we can see that the most growth, though, is between 5 and 35. And then the big thing here at the end, generally sales growth in the Northwest were higher, yes. Okay, and there's less variable, yes. These are a lot less variable than they are in the South. In the South, you won't really know how much money your store is going to make. Okay. All right, so the correct answer there was B. All right, multiple choice. I like multiple choice. It goes faster and I don't have to write as much. Okay, so we're looking at the comparison here, weekly salaries. All right, so you can kind of look at it. I did a little eliminating because right here it says we want to make a modified box plot. So modified box plot. Well, these are not modified box plots. They go the whole way. These guys look like modified box plots. Okay, so what we want to do, then check through our data. Okay, check if there's, where the median lies. Well, the median here, if you start crossing them off, you'll find that the median arrives somewhere in the middle here, which would be 2. So the answer there would be 2. Okay, that is your modified box plot. On the bottom, okay, we have normal annual precipitation, my bad. is given below for 21 cities. So we want to know if there's any potential outliers. Well, we've got to find our fences. So lower fence, upper fence. Okay, and if you find the lower fence, it should be negative 2.45. Upper fence was 58.75. So actually, bam, A would have been your answer. Okay, 59 and 63 all are to the right or larger than our upper fence, so they would be considered outliers. There's nothing below. Okay. All right. Next page. Continuing with our multiple choice. Okay. Looking at the stem and leaf play, we look at D is the answer for this. We expect the mean to be higher than the median, okay, because this is right skewed. Okay, most of the things are down here. We have our couple of 65. It's dragging that mean higher. Okay. Response to this graph. So we can see this is left skewed. Okay. So obviously it's not skewed to the right. The mean would be smaller than the median. Yes, because the mean would be going down left. And then we should use median and IQR. Absolutely, because this is skewed data. So the question answer there would have been E. So here I'll fill them in. D, E, in case you don't like my circling. Okay. And then the last one, short answer. So now we got to go right again. They did give us our 5-number summary, okay, and the repair bills. So we want to know if there's outliers. So again, finding the upper and lower fence. So the lower fence turns out that it doesn't have any, okay. You're going to get a nice negative number there. But the upper fence, okay, is going to be 308 and 330, which was 638. So this is our upper fence. Well, right here, our max is 1442. So yes, there are outliers, okay? And we found that by figuring out our upper fence and then comparing, okay? All right, so getting here, second to last page. We're almost done, okay? Again, they give us our 5-number summary, and again, we're looking for outliers. So find the lower fence, find the upper fence. We're going to be fence masters by the end of this. Our lower fence was 8.85. Our upper fence, 25.55. Well, bam, right here, max of 25.8. So yes, okay, 25.8 is an outlier, okay? Because, oh, and the min, my bad. Wow, look at that. The min would also be an outlier, and 7.9. I should look at my own notes before writing, okay? Because that was down of my lower fence, 25.8 is bigger than my upper fence. So there are 2 outliers right there, okay? All right, and the last multiple choice problem here, number 7. We're comparing Caroline and Alexandra, okay, of their points during a basketball game. And if you compare them up, like D is our answer. Okay, both girls have a median score of about 18. Yes. Okay. However, Caroline is much more consistent. Okay, look at her range and IQR, they're much closer together because her IQR is only about 4 points, while Alexandra's is well over 15. Okay, so she has she's much more variable than Caroline is. Okay. Ooh. All right, yes, and then the last page. Okay, now I know why I did this. Okay, our modified box plots. Okay, the first one should look like, oops, sorry people. All right, should look like this. All right, so the box plot goes from 100. And median was about 114. Okay, Q3 118. Then we have to stop at our last outlier of last number of 128. That's the biggest number that's not an outlier. And then our outlier was 134. Okay, then on the bottom, number 9, This is a modified box plot, but there is no outlier. Okay, so we can go all the way to from the min to the max. Okay, with our median right there at 77. Okay, so kind of compare them. I know my drawings aren't very good. Yours are probably so much better, but they should look just like this. Okay, all right. I will see you guys tomorrow.